Hello everybody, today we'll be solving Leetcode 2257, count unguarded cells in the grid. So essentially they want us to return the number of unoccupied cells that are not guarded. So we'll be using breadth first search, and we'll be starting with the guards as we perform our breadth first search. We'll also be using a grid to store which cells are occupied and which cells are guarded. Now it's important to know that a guard can perform a guarding if its vision is unobstructed. So let's go. Let me demonstrate that a little bit. And for my example, what I'm going to do is actually put maybe a guard here. Okay. So let's begin. So as we use our breadth first search to discover which cells are guarded. Suppose we are at this guard. We would look to the left and we'll say, okay, we'll guard it. Assuming that we've never explored any of the guards before. We look down, we'd end up guarding these two cells. Look to the right, guard this, guard this. When this guard approaches this guard, it would stop its search because in essence, this guard would know that this guard eventually would continue on in that very direction. So it doesn't need to we don't need to do twice the work. Let's move on to this guard. This guard, for example, guard to the bottom with no problem. Guard to the right with no problem. When it attempts to guard to the left, its view would be obstructed, so it would not be able to guard anything to the left. It's already occupied in essence. However, when we search to the top, so notice there isn't a guard there and there isn't a wall there. So it can continue on, and it will. So what we'll do is we'll maybe mark everything that's a guard and a wall, maybe start off with once, and then we'll use some other marker for the open cells. So initially we'll set a grid, and we'll set all the green cells, or every cell initially to 0. I'm not going to mark everything 0, but once we move on to cells that are guarded by being on the same row or column, we can indicate that by maybe we'll use a sentinel value of 2, and that'll just help us when we're performing our exploration. So for example, when this cell moves on to this cell, it sees a 2 and it says, okay, that means you're just guarded because you're in another guard's vision. But I can, even though the guard's visions overlap or intersect, this guard is still allowed to continue on in that very direction. And that's basically it. So I guess we can start coding it now. So we'll start off by initializing an empty grid. I'll just call it maybe D. And now we'll populate wherever we see a guard or a wall. We'll indicate that by placing a 1 in that cell. Okay, so now we know that anything with any cell with a 1 in it indicates there's a guard or a wall there. What I like to do also is maintain a constant that stores all of the directions. Okay. And now we'll start exploring from each of the guards. And from every guard, we'll check every direction. Now what we need to do is once a guard starts off by exploring a direction, so for example, this guard, and he goes off in this direction, we need to go as far as he can. So we need to implement that code-wise. So we'll do that here. So what we'll do is, so for every direction, we want to know where we're starting off at. So we need to store that. So I'll do something like this. RC equals row column. So for every direction, we'll store where we started off at. Now what we want to do is we want to check if we're allowed to go in that particular direction. If that direction is within the bounds of the entirety of the grid. So let's perform that check. So while 0 less than or equal to r plus dr. And what else we need to do, as I mentioned earlier, was we need to, the only cells that we can explore are cells that have a 1 in it. So we're allowed to look at anything that's a 0 and a cell that has a 2 in it. Remember, the 2 means that it's just guarded by eyesight or being in the same row or column. So let's do that. Now how can we do it? How can we do that? We just say, well, we know that if there's a wall there or a guard there, we know it's 1 from up here. So we just need to check that cell is not 1. And actually, I'm going to minimize this. Let's clear that. So where are we now? Okay, so if we're in this loop here, that means that cell is okay to move forward into. And so we're going to adjust this row and column. So we'll set R and C equal to row plus dr, column plus dc. And we'll mark that cell with a, remember 0 means it's completely empty, 1 means it's a guard or a wall. We're going to use a 2 to indicate that it's guarded, but guarded by being in the same row or the same column of the guard. And we're pretty much done. What we could do is maybe put some comments here. So if there's a 1 there, it's an obstacle, and if it's a 2, it's viewed by the guard. And so remember, the task was to return all unoccupied cells that are not guarded. So anything that has, remember, we initialized the cells to zeros. So what we want to do is we want to count the number of zeros. So let's do that. So what I'm going to do is use the sum up the zeros for every row. So for row in D, and Python provides a helper function, so I can use this row.count, and I'm going to count the zeros. And I'm going to sum up for every row. I'm going to sum up all the zeros, and we're going to return that. And I like to check it before I submit it. What the hell happened here? 0, 1, 1, 0, negative 1, 1, 0. Oh, I see now. Here, so I was checking if the if the row plus dr is in the bounds and the column plus dc is in the bounds, but I still I didn't take that into account here. Cool. And that looks fine. Okay, great. Looks good. 90 is good. I like these little high fives or hand claps. All right. I hope you have a good day. If it was informative or instructive, comment, like, subscribe. Have a great day. See you next time.